Imagine not just one, but countless universes, each with its own unique laws of physics, dimensions, and even time. Welcome to the concept of multiple universes, a fascinating notion that will challenge everything you thought you knew about existence. We're not just talking about a couple of extra galaxies, but an endless number of universes, each with its own unique reality. This isn't just the stuff of science fiction, but theories proposed by some of the world's leading physicists. We'll explore the mind-boggling ideas of the multiverse concept, the many worlds interpretation, and the implications of string theory. We'll dive into theories of bubble universes, brain worlds, and quantum multiverses. And we'll even touch on the philosophical implications and the portrayal of these concepts in popular culture. Prepare to have your mind expanded as we delve into the fascinating realm of multiple universes. The multiverse, a term that has stirred imaginations and sparked countless debates. The concept of a multiverse, as the name suggests, refers to a hypothetical set of multiple or many universes, including the one we inhabit. These universes together comprise everything that exists, the entirety of space, time, matter, energy, and the physical laws and constants that describe them. Now let's try to wrap our heads around this. Imagine a cosmic quilt of sorts where each patch represents a universe with its own unique laws of physics and properties. Our universe is but one patch in this infinite cosmic quilt. But where does this idea come from? The roots of the multiverse concept can be traced back to quantum mechanics, the scientific theory that describes the bizarre and counterintuitive behaviors of particles at the microscopic level. Quantum mechanics introduces the concept of superpositions, the idea that a particle can exist in multiple states at the same time until it is observed or measured. The multiverse theory is an extrapolation of this concept, suggesting that for every possible outcome of a decision, the universe splits into different versions, each version witnessing a different outcome. Sounds like the plot of a science fiction novel, doesn't it? But this is serious scientific conjecture. However, it's crucial to note that the multiverse remains a hypothesis. While it provides a fascinating framework to explain certain phenomena, it is yet to be proven. It's a concept that pushes at the boundaries of our understanding, challenging us to reconsider our place in the cosmos. The multiverse is indeed a mind-bending concept, one that opens up a world, or rather, worlds of possibilities. It invites us to imagine a reality where there are infinite versions of ourselves living out every conceivable narrative. But this is just the tip of the cosmic iceberg. Let's dive into the quantum realm and meet the many worlds interpretation. Now, this isn't a sci-fi movie plot, it's a genuine implication of quantum mechanics, one of the most successful theories in all of physics. This interpretation takes us on a thrilling adventure where every quantum event results in a branching of universes. Imagine you're flipping a coin. In our familiar world, it'll land either heads or tails, right? But not in the many worlds interpretation. Here, the universe splits into two, one where the coin lands heads and another where it's tails. Mind-boggling, isn't it? Well, that's quantum mechanics for you. This interpretation was first proposed by Hugh Everett in the 1950s. He suggested that we don't have to collapse quantum wave functions into one outcome. Instead, all possible outcomes of a quantum event exist in separate parallel universes. So, every time you make a decision, from picking a breakfast cereal to choosing a career, the universe splits into countless versions, each representing a different outcome. In one universe, you might be a world-renowned scientist, while in another, a rock star performing in front of thousands. It's a concept that stretches our imagination to its limits, and it's not without its critics. Some physicists argue it's untestable and strays into the realm of philosophy rather than science. But others see it as a natural and even inevitable interpretation of quantum mechanics. It's important to note that these aren't parallel universes in the sense of being right next to each other or interacting with each other. They are entirely separate and independent. You can't pop over to a universe where you're the president or a movie star, at least not yet. In this view, every choice you make creates a split in the universe, where one version of you continues in the universe in which you made a different choice. It's an idea that's as fascinating as it is bewildering, And it's just one of the many ways that quantum mechanics continues to surprise and confound us. Scene script. String theory brings a new twist to the multiverse concept with the idea of parallel universes. Imagine a world where everything is exactly the same as ours, but with one key difference. Perhaps in this world you decided to have tea instead of coffee this morning. This kind of mind-bending scenario is what string theory, one of the leading theories of quantum physics, suggests could be a reality. Now, string theory is a complex beast. At its core, it proposes that the fundamental building blocks of the universe aren't particles, but tiny, vibrating strings of energy. But the real kicker is that these strings aren't just confined to the 3 dimensions we experience. Instead, string theory suggests that there could be up to 10 dimensions, most of which are curled up so small that we can't perceive them. So how do parallel universes fit into this? Well, if we have all these extra dimensions, then it's possible that our universe, the one we live in and experience, is just one slice of a much larger dimensional cake. Each slice, or brain, as physicists like to call them, could be its own universe with its own laws of physics, its own galaxies, stars, planets, and maybe even its own forms of life. These are the parallel universes that string theory predicts. But it doesn't stop there. Some versions of string theory suggest that these brains could interact with each other. When they collide, the energy released could spark the creation of a whole new universe. This is one possible explanation for the Big Bang. The event that created our universe could have been a collision between 2 of these parallel universes. Of course, all of this is purely theoretical. We don't have any direct evidence for the existence of these parallel universes, but string theory is a powerful tool that's helped us make sense of some of the biggest mysteries in physics. And who knows? Maybe one day we'll find a way to test these predictions and prove that we really do live in a multiverse. It's a concept that might sound straight out of science fiction, but for some physicists, it's a serious possibility. Now let's inflate our understanding of the multiverse with the concept of bubble universes. The idea of bubble universes arises from a theory known as cosmic inflation. This theory posits that shortly after the Big Bang, the universe expanded rapidly in a burst of inflation. Imagine blowing up a balloon. As you inflate it, the surface of the balloon expands, right? Now picture this on a cosmic scale. Our universe, in the early moments of its existence, underwent a similar, albeit far more dramatic expansion. But here's the twist. Cosmic inflation didn't stop everywhere at the same time. In some regions, inflation continued, creating what we call bubbles. Our universe, according to this theory, is just one such bubble. It's a region where inflation has stopped, giving rise to galaxies, stars, planets, and us. But beyond our observable universe, beyond what we can see with our most powerful telescopes, there could be other bubbles. These are regions where inflation has also stopped, possibly giving rise to other universes with their own galaxies, stars, and planets. These bubble universes could be incredibly numerous, forming a vast cosmic foam. Each bubble could have different physical properties, governed by different laws of physics. Some might be similar to our own universe, others might be utterly alien. And just as bubbles in a bath can occasionally collide, so too could these bubble universes. If our universe were to collide with another, it could potentially be detectable. Some scientists are even searching for signs of such a cosmic collision in the cosmic microwave background radiation, the afterglow of the Big Bang. This theory suggests that we could be living inside a cosmic bubble, with countless others floating around in a larger multiverse. The concept of bubble universes adds another layer to the already mind-bending idea of the multiverse, further stretching our understanding of reality. It's a fascinating theory, and one that continues to be explored by cosmologists today. Everett's many worlds takes the multiverse concept to a whole new level. This interpretation of quantum mechanics suggests that all possible alternative histories and futures are real and exist in a multitude of parallel universes, each representing a different possible outcome of a quantum event. Quantum mechanics, the branch of physics that deals with the smallest particles in the universe, is famously strange and counterintuitive. One of its most bizarre implications is that an unobserved particle exists in a state of superposition, meaning it can be in multiple places at once. It's only when we observe the particle that it appears to snap into one position. Hugh Everett, a young doctoral student at Princeton University in the 1950s, proposed a radical solution to this quantum weirdness. He suggested that there's no such thing as a single outcome of a quantum event. Instead, all possible outcomes happen, each in a different universe. This is what we now call the many worlds interpretation. But let's take this a step further with the quantum multiverse concept. It suggests that the universe splits into different realities with every quantum event, not just when we observe it. This means that for every possible outcome of every event, there's a branch of reality where it happens. Think of it as an endlessly branching tree. Each branch represents a different universe, and each twig on each branch represents a different outcome of a quantum event. The universe we live in is just one of those twigs on one of those branches. But there's more. Quantum fluctuations, tiny variations in energy that occur randomly, could potentially lead to the creation of new universes. These quantum fluctuations could cause a universe to tunnel from one state to another, creating a whole new universe in the process. This idea, known as quantum tunneling, is still highly speculative and controversial. But if it's true, it means that the multiverse is constantly growing, with new universes being created all the time. In this view, the universe we know is just one of an infinite number of realities. String theory presents us with a vision of a vast cosmic landscape. In this theoretical framework, it's not just one universe that exists, but an almost infinite variety of them, each with their own unique set of laws and physical constants. Imagine a landscape stretching out in all directions with peaks and valleys, each representing a possible universe. These universes are not just distinct in terms of their physical laws, but also in terms of the values of their physical constants. For example, the strength of gravity or the speed of light could vary from one universe to another. This cosmic landscape is like a gigantic patchwork quilt, with each patch representing a different universe. Each patch, or universe, is governed by a specific set of string vibrations. These vibrations determine the properties of the universe, such as the types of particles it contains and the forces that govern their interactions. The concept of a cosmic landscape introduces an element of randomness into the picture. The type of universe that forms in a particular region of the cosmic landscape depends on the precise details of the string vibrations in that region. This means that the universe we find ourselves in is not necessarily unique or special. It's just one of an almost infinite variety of possible universes that could have formed. However, this doesn't mean that all universes are equally likely. Some regions of the cosmic landscape may be more conducive to the formation of universes than others. This could explain why we find ourselves in a universe that seems finely tuned for our existence. It's not that our universe is necessarily special, but rather that it's located in a region of the cosmic landscape where universes like ours are likely to form. In conclusion, the cosmic landscape in string theory presents us with a vision of a multiverse that is vast and varied. It provides a framework for understanding why our universe appears the way it does and opens up the possibility of other universes with vastly different properties. This vision of the multiverse proposes a mind-boggling array of possible universes, each with its own unique properties. We've journeyed through a multitude of theories about multiple universes. We've traversed the many worlds interpretation of quantum mechanics, where every quantum event could result in an endless branching of parallel universes. We've explored the concept of our universe being a mere bubble in a cosmic foam, each bubble representing a different universe, a testament to the grandeur of inflationary cosmology. We delved into the brain-world hypothesis and its implications of our three-dimensional world being a membrane in a higher dimensional space. We've also ventured into the fascinating world of string theory, a theory that suggests the existence of parallel universes within extra dimensions. We've pondered on the quantum multiverse concept, a theory that goes beyond Everett's many worlds interpretation, suggesting that quantum fluctuations could lead to the creation of multiple universes. We've contemplated the idea of cyclic universes, universes that go through repeated cycles of creation and destruction, a cosmic ballet of birth, death, and rebirth. We've navigated the vast cosmic landscape in string theory, a theory that suggests a diversity of physical constants that could give rise to a multitude of universes. We've considered the observational challenges, the philosophical implications, and the influence of these theories on pop culture. We've even dipped our toes into the debates and critiques surrounding these theories within the scientific community. In this whirlwind tour of the multiverse, we've only scratched the surface of this fascinating and complex concept. The idea of multiple universes challenges our traditional notions of existence and reality. It invites us to think beyond our universe, to consider realities that are wildly different from our own, and to ponder the endless possibilities of existence. Whether you're a budding physicist or just a curious mind, the multiverse is a concept that continues to challenge our understanding of reality and ignite our imaginations. So continue to explore, continue to question, and continue to marvel at the wonders of the multiverse. After all, who knows? There might just be another version of you in a parallel universe doing the same.